Fusion energy breakthrough, behind the scenes at ITER. Imagine a future where clean, limitless energy flows from the very reaction that powers the sun. This is not science fiction anymore. It's happening step by step inside a vast international experiment known as ITER, the International Thermonuclear Experimental Reactor, based in southern France. Scientists call it one of the most ambitious energy projects ever attempted, and today, we're going behind the scenes to uncover how close humanity really is to unlocking the power of the stars. Fusion is different from the nuclear power most people know. Instead of splitting atoms, fusion merges light atomic nuclei, usually isotopes of hydrogen like deuterium and tritium, into heavier ones, releasing staggering amounts of energy in the process. Just a few grams of fuel could generate as much power as tons of coal, but with no carbon emissions and almost no long-lasting radioactive waste. The challenge? Reproducing the sun's extreme conditions here on Earth and keeping a plasma, hotter than the core of the sun, contained long enough to produce net energy. That's where ITER comes in. Stretching across a site the size of 60 football fields, ITER brings together 35 nations, thousands of engineers, and decades of theoretical research. Its goal is not just to make fusion work for a few seconds, but to demonstrate sustained burning plasma for the first time in history. For the world's energy future, this milestone could be as transformative as the invention of electricity itself. So, how does it all work? At the heart of ITER is a machine called a tokamak, a donut-shaped magnetic chamber designed to confine superheated plasma. Massive superconducting magnets, some taller than buildings, generate magnetic fields powerful enough to hold and twist plasma like an invisible cage. Inside this chamber, temperatures soar above 150 million degrees Celsius, 10 times hotter than the sun's core, while the reactor walls remain cool, protected by advanced materials. It's a delicate balance. One slip and the plasma collapses instantly. To understand these breakthroughs, we spoke with physicists working inside ITER. Marie-Laurent, a plasma scientist, explained, "We're not just controlling fire, we're controlling a star in miniature. Every fraction of a second teaches us more about how to tame plasma and stabilize fusion reactions. Each milestone brings us closer to net energy." Another engineer, David Chen, shared how the assembly of ITER's central solenoid, often called the beating heart of the tokamak, was a moment of awe. It's the largest magnet ever built. Once fully operational, it will drive the plasma current that keeps everything in motion. It's like switching on the sun. Recent milestones at ITER include the successful installation of superconducting coils, the first integrated plasma tests, and breakthroughs in plasma containment stability. Visuals from inside the facility reveal a cathedral-like structure where massive steel segments are lowered into place with millimeter precision. Scientists from different continents collaborate daily, blending knowledge from Japan, India, the US, Europe, and beyond. This isn't just physics, it's humanity pooling its brightest minds for a shared dream. But why does this matter? Imagine a world where cities are powered without fossil fuels, where climate change is reversed not by sacrifice but by abundance, and where energy is as clean as it is infinite. Fusion promises that future. Of course, challenges remain. ITER's first plasma is scheduled within this decade, and demonstrating net positive energy is still a monumental task. Yet, compared to where we stood 50 years ago, the progress is breathtaking. For viewers, the behind-the-scenes journey is as inspiring as the science itself. You'll see the towering magnets, the shimmering plasma simulations, and the faces of scientists who dedicate their lives to bending nature's most powerful force. You'll hear their voices filled with equal parts struggle and hope, reminding us that every discovery is built on countless failures turned into lessons. As we close this chapter of exploration, remember this: the sun overhead has been burning for 4-5 billion years, and now, on Earth, we are learning to light our own miniature suns. ITER is not just an experiment. It is a symbol of what humanity can achieve when curiosity meets courage, and when nations choose collaboration over competition. Fusion energy may still be a work in progress, but behind ITER's doors, you can already feel the future humming. Like and subscribe.